James Ferguson's mechanical paradox began, according to his own account, during an evening gathering in which a watchmaker openly mocked the doctrine of the Holy Trinity, calling it absurd and contrary to reason. Ferguson did not answer him with theology. Instead, he chose to speak to the man through his own craft, the working of wheels and gears. From that exchange came the famous mechanical paradox, a device that seemed impossible when described, yet worked when built, and served as Ferguson's lesson that not everything beyond our understanding is therefore false. Sir, since you are well acquainted with watches and wheels, let us speak for a moment about your own trade. Do you understand how one toothed wheel turns another? I certainly hope so, sir. A watchmaker who did not understand that would be a poor watchmaker indeed. Then suppose you make one wheel as thick as 3 others, and cut teeth upon them all. Place the 3 thin wheels loose upon the same axis, and set the thick wheel against them, so that its teeth engage with the teeth of all 3. Now if you turn the thick wheel, how must it turn the others? Sir, that question is almost an insult to common sense. Anyone who knows the least thing about wheels must know that, whichever way the thick wheel turns, the 3 thin wheels must all turn the opposite way. I believe, sir, that you are quite convinced of that. Convinced? It is not merely a matter of opinion. It is certain. It must happen so. Be careful, sir, that you are not too certain. You may yet be mistaken. What would you say if I told you that no matter which way you turn the thick wheel, it will turn one of the thin wheels the same way, another the opposite way, and the third not at all? I would say, sir, that nothing more absurd could be imagined. Such a thing would not merely be beyond reason, it would be contrary to reason. Very well. Now tell me, in your view, is there anything in the accepted doctrine of the Trinity more absurd than this proposition of mine? No, sir. And if I could believe one, I suppose I could believe the other. Then I shall make such a machine and bring it here next week, so that the company may judge whether the thing is truly impossible. The following week, Ferguson returned with the apparatus and placed it before the company. Here is the machine, sir. Examine it carefully and tell us how it works. The watchmaker turned it one way, then the other. He took it apart, studied the wheels, put it together again, and tried once more. At last, he admitted that he was completely perplexed. Sir, this thing is not only beyond reason, it seems contrary to every principle of mechanics. For shame, sir. Do not ask me how it is possible. This is a simpler machine than any clock or watch you have ever made or repaired. If so simple a device, in your own profession, can leave you so confused, then it is no wonder that greater mysteries should trouble you even more. Learn from this, then. Do not call something absurd or impossible merely because you do not understand it. Let us now learn how to build Ferguson's paradox mechanism so that we may then understand how it works. First, place 2 planet gears in series. Set each of them to 30 teeth. Then add 2 more similar planetary gear systems. Here comes the first secret of the mechanism. On the last gear of the second planetary system, set the number of teeth to 31. On the third planetary system, set it to 29 teeth. Now make the proper couplings. The sun gears must behave as a single unit. Next, couple the carriers of the planetary systems. Then couple the first planet gear of each planetary system, so that they also behave as a single unit. Set the angular velocity of the sun gear to 0. Notice that, at the beginning, all the red gears are aligned. Set the carrier speed to -100 RPM so that it rotates clockwise. Observe how one of the gears does not rotate, another rotates clockwise, and the last one rotates counterclockwise. When the planetary system is stopped, we can see how each gear has behaved. They truly rotate in 3 different ways. But how does this work? Let us rotate only the sun gear. All 3 gears rotate in the same direction. The differences in their speeds are due to the number of teeth on the red gears. With a difference of 1 tooth in each case, the speeds vary by about 3 RPM. If the sun gear rotates at 100 RPM counterclockwise and the carrier is fixed, all the red gears rotate in the same direction, just as the watchmaker predicted. But if the sun gear is fixed and the carrier rotates at 100 RPM clockwise, it cancels 100 RPM from the red gears. Thus, one rotates clockwise, another rotates counterclockwise, and the last does not rotate at all. Let us understand the mathematics behind it. When using the general formula for planetary gears, the idea is that when calculating the speed ratio of the last gear in a train relative to the first gear, with both measured relative to the carrier, the expression can be written as the angular velocity of the last gear minus the angular velocity of the carrier, divided by the angular velocity of the first gear minus the angular velocity of the carrier. This is equal to the train value, which is the product of the numbers of teeth of the driving gears divided by the product of the numbers of teeth of the driven gears. For this example, when assembling the train 1, 2, 3, the equation can be applied as shown. Returning to Ferguson's mechanism, when the carrier is fixed and the sun gear rotates at 100 RPM counterclockwise, the 3 red gears rotate in the same direction with slightly different speeds because they have 30, 31, and 29 teeth respectively. Notice how the equations demonstrate the rotation values. Now, when the sun gear is fixed and the carrier rotates at 100 RPM clockwise, each of the gears has a different speed with different directions of rotation. For gear 3 with 30 teeth, the speed is 0, so it does not rotate. For gear 4 with 31 teeth, the speed is 3.23 RPM clockwise. For gear 5 with 29 teeth, the speed is 3.45 RPM counterclockwise. By changing only a single tooth in each of the gears, Ferguson managed to create a mechanism that seems to defy logic, but which has a perfectly plausible explanation.